Gonioscopy consists of examination of the iridocorneal angle. Examination of this dihedral angle, where is located the main aqueous humor outflow pathway, constitute an essential time of clinical examination by allowing precise and detailed analysis of the structures of this essential zone in ocular physiology. When correctly performed, it avoids the need for other investigations, not always essential. Finally, it can be completed by dynamic examination in order to distinguish open from closed angles. Integral part of the clinical ophthalmological examination in all patients, gonioscopy must be systematic in the assessment of all forms of glaucoma and any suspicion of narrow angle. Examination must answer three questions: is the angle open, closed, or suspicious of angle closure that requires a good knowledge of anatomy and of its physiological and pathological variations. Analysis must identify the various structures, determine its degree of opening, examine the periphery of the iris, flat, convex, or concave appearance, to estimate the site of insertion of its root, determine the degree of pigmentation, and note the existence and the site of iridotrabecular apposition or anterior synechia. Various types of lenses can be used to visualize the angle. Goldmann lenses with the single mirror lens, or the smallest of the three mirror lenses. Zeiss rich Postner 4-mirror lenses. The Postner 4-mirror lens provides maximum visibility with minimum rotation. It does not require interposition of fluid, and its 9 mm diameter allows indentation for dynamic gonioscopy. The examination must respect several recommendations, especially the need to maintain the anterior surface of the lens vertical to avoid artificially modifying the anatomical relations and skewing their identifications. However, the examination is sometimes difficult, with often an approximate localization of the abnormalities. Acquisition of reference image is rare, with no precise topographic determination. Monitoring of the course of all abnormality remains difficult, and these limitations explain why gonioscopy is rarely repeated in clinical practice. These various points have led to the development of an innovative iridocorneal angle imaging technique, automated gonioscopy. Based on the concept of an electronic image acquisition system adapted for an acquisition over 360 degrees. The gonioscope uses a contact prism incorporating a Goldmann lens and a series of 16 silver-coated faceted mirrors to observe the various sides of the angle. The tip of the lens comes in indirect contact with the ocular surface via a 1.5 mm thick disc of ophthalmic gel on the surface of the prism. A red fixation point helps the patient and facilitates alignment of the prism. During contact of the gel with the eye, automatic alignment of the device in the X and Y axis is completed by manual focusing in the Z axis. At this stage, correct alignment is facilitated by simultaneous observation of the four nasal, superior, temporal, and inferior sectors of the angle, allowing focusing for the start of the acquisition. The LED light source and the Sony camera image acquisition system use different optical channels for a quicker acquisitions. 17 images are required from each facet of the prism on a focal length of 5 mm. And here we can see in slow motion the 17 images for a facet with 2 or 3 images with a good visualization of the various structures of the angle. Real-time acquisition here is continued on all the facets of the prism. A rotary function scans all facets of the mirrors in order to acquire images of each person of various focal planes. Image acquisition is performed on a depth of 5 mm due to the fact that the corneoscleral limbus and iridocorneal angle are not circular, thereby ensuring optimal acquisition of a sharp image of the angle over its entire circumference. At the end, images of the various focal planes can be examined for each facet. High-resolution images obtained are used to analyze the anatomical landmarks of the angle, assess its degree of opening, observe the periphery of the iris, and determine the degree of pigmentation. Each image covers a field of about 4 mm, about 38 degrees, with a lateral overlap of about 20%. Operator-controlled preselection of the most sharply focused images from each facet is possible. The software creates an assemblage image of the 16 images, providing a linear and circular 360-degree representation of the angle that can be used for topographic analysis. The image of the angle obtained at the end of an examination lasting about 1 minute can be used to analyze the various anatomical landmarks. The degree of opening can be assessed, the peripheral iris plane can be observed, and its insertion site estimated. Finally, analysis of iris pigmentation can also be performed on the circular image of the angle. Comparative analysis of the angle of the two eyes can be performed. Abnormalities detected and recorded are localized with here numerous angle processes. Control of peripheral iridotomy and its site are saved. Postoperative verification of angle surgery is possible. The correct site and efficacy of surgery can be verified satisfactorily in the upper image and less functional in the lower image. And correct positioning of angular material can also be demonstrated and documented. Finally, the site of non-penetrating infiltration surgery can also be verified and documented. The limitation of automated gonioscopy include a necessary learning curve, compliance with a certain number of instructions for use, and especially the impossibility of dynamic examination to distinguish anterior synechia from iridotrabecular apposition. Automated gonioscopy therefore provides rapid access to data of the angle, with precise topographic localization of any abnormalities, a longitudinal follow-up of all angular illness. It facilitates regular follow-up of the angle in glaucoma and in narrow angle or angle closure. Post-operative verification of MIGS with data storage highlight the value of this system for training and teaching, as well as its potential medico-legal value. Finally, the ongoing development of measurement indices is also promising. By providing rapid visual access to the angle, automated gonioscopy, even limited by the absence of dynamic examination, has the advantage of ensuring more frequent examination of this essential zone in clinical practice.